Welcome. So this question says how much energy is stored in a 6 farad capacitor that holds a charge of 5 coulombs. So I'm envisaging a capacitor and it's been charged by something. I don't know what it is, but it's got a whole bunch of charge on here, and that's 5 coulombs, and it's a 6 farad capacitor. So let me say off the bat that there's a mistake that people when they first begin often fall into, which is, if you think about it, charge measured in coulombs and capacitors measured in farads. Can you see how C appears twice? Once as the symbol we use as a symbol for capacitance, and another time as a unit for charge. And if we were writing a textbook, I'm sure we'd make the fonts, noticeably different. But when you're writing by hand, if you're not careful, it's very easy to get those two C's confused. And if you just look at somebody else's notes, there's a C and you're not paying that much attention, it's very easy to get those two confused. Is he talking about C capacitance or C as the unit of charge? So you've got to be just a bit careful about that. We ran out of letters a long time ago, and we're having letters to be used for 5 different things, and so context is everything. So don't fall into that trap. What happens with this is we begin, if we imagine just plotting a graph of charge versus voltage, what we see is as we have more charge, we have more potential difference, and what we'd see is we'd get an increase like that. And what we'd say is, oh well, charge is in coulombs and voltage is in joules per coulomb. So that means that if I take the area under the graph, I have joules per coulomb multiplied by coulombs gives me joules. That's where my energy storage is. So I can say, just by looking at the graph, oh well, my energy, let's call it E, is equal to, it's a triangle, so it's a half Q times V. Well, what do I know from today's question? I know that my capacitance is 6, and I know that my charge is 5. So not quite in the right terms. Well, of course, let's not forget that charge equals VC. So now I can just do a substitution. I want to basically have the thing in capacitance and charge, so I want to get rid of my volts. So I can say my energy equals 1/2 Q times my voltage. My voltage equals Q over C, which equals 1/2 Q squared over C. So my energy is equal to 1/2, and my Q is 5 squared over my C, and my C is 6, which gives me, what's that, 25 over 12? And 25 over 12 will be 2.1. Okay, 25 over 12 joules. There's my answer. Let's do another one. So this says how much energy is stored when a capacitor, 9 farad capacitor, is fully charged by a 4-volt battery. So it's a different visualization. Here I have a 4-volt battery and I have this capacitor, and this is 4 volts, and this is the capacitor, and the capacitor is 9 farads. So that's 9 farads. And again, because of the voltage, I have it fully charged. I'll draw just two signs on. So we're at this situation where we're fully charged, and actually I know when this thing is fully charged that the potential, the EMF supplied by the battery is dropped as a potential difference across here. So I can have 4 volts potential difference. The EMF in the power supply becomes the potential difference in the circuit. This only has one component, so all 4 volts must be dropped across the capacitor. Well, my energy is still the same thing, so my energy is equal to 1/2 Q times V. And this time, what do I know? I know my V is equal to 4 volts, and I know my C is equal to 9 farads. And again, it's not quite in the terms that I want, so I got to remember that Q is equal to VC. And this time, I don't want to have the capacitance. This time, I don't want to have the charge in it, and so I'm going to say, well, E is equal to 1/2 VC times V, which equals 1/2 V squared times C. So my energy is equal to 1/2, and the V was 4, so that's 4 squared times my capacitance is 9, which gives me 16 times 9 over 2, which equals 8 times 9. 9 8 is 72. So that's 72 joules on here. So 2 different types of questions. You know, you've got 3 parameters, potentially 3 different unknowns, so you need different equations, and you have a choice. You can either learn 3 versions of the energy equation, or you learn one of the equations of the energy equation, and you remember that Q equals CV. So you remember this, and you remember that. Or in addition, if you do enough of them, you will remember. It's not elegantly drawn, but you'll remember. Oh, that's the V disappeared, didn't it? You remember that. You know, you just remember the equations. But if not, just remember this base equation here. Sorry, my pen's disappearing on me. Remember this base equation here. Remember this base equation there, and you can figure out the rest. And then remember, I can talk about just the capacitor. I can tell you the setting of the capacitor, and there you have to do some conceptual stuff where you have to be able to recognize that 4 volts on an EMF is going to produce a 4 volt potential difference once the capacitor is fully charged. So there's a bit of conceptual understanding there as well. It's never just get an equation and plug in some numbers. It's never as simple as that. So there we have it.